Again, yes. Hello again, sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT from Weather Risk, your captain of chaos, your colonel of confusion, your commander of catastrophe. Let's talk about the February 19th, 20th, potentially major East Coast snowstorm threat. So we're doing this here on Saturday evening around 10 p.m., and hopefully, this information is going to be useful to everybody, and they can see what exactly is going on. So we're going to try and go through this pretty quickly. Now, I want to introduce some new values here. This is the RSI, Regional Snow Index. If you don't know what that is, you can Google the term, and you'll see a lot of information on there. This is a national scale, sort of like the Saffir-Simpson scale for figuring out and evaluating snowstorms in the plains, the Midwest, the Deep South, and the Northeast. So the RSI values for the southern region for this storm is estimated between 10 to 15, which is a low in Category 4. Now, that's because the southern region has a different criteria for big snowstorms than the Northeast or New England or the Great Lakes, obviously. For example, 8 inches of snow in Raleigh is a big deal, but 8 inches of snow in Binghamton, New York is not that big of a deal. Okay. The RSI values for the Northeast region is around 9 or 10, which is a high-end Category 3 if all the model data works out. But these are estimates, okay? And then the Nessus value, which is Northeast Snowstorm Index, you can see this estimate is between 8 and 10, which is a high-end Category 4 crippling snowstorm. That's what we're looking at. The Nessus area covers from North Carolina up to Maine, okay, and then out to the Pennsylvania-Ohio border. So it's a little different scale here. The Nessus is just for the Northeast U.S. We'll start out by taking a look at teleconnections, as we usually do, but just briefly going over it here. On the Pacific side and the Atlantic side, we have two teleconnections here on the Atlantic. On the Pacific side, the EPO and the PNA, and the Arctic and the NAO here. We go to the data quickly, we'll see that in fact it remains, oops, let me get rid of that here. That's not what I wanted. Let me go back to this one right here and copy block this arrow so I have it for the rest of the display. And then we can see here the Arctic oscillation. Again, right now it is strongly negative. You want to see that for snowstorms and for a lot of cold in the eastern United States, especially when it's combined with the NAO, which is the Greenland block or Greenland low, or Quebec or Labrador. And as you can see, it also is very negative right now. So both of these are very negative. And as we approach the 19th to 20th, there's a phase change. It's going from being strongly negative to strongly positive. This is very common with East Coast snowstorms and a strong signal that something big is going to happen. This is recent research. A lot of meteorologists out there don't know about this, but that's okay. So I just point that out to you. The Pacific side doesn't matter as much at this point because the event's only 4 days away. But on the Pacific side here, again, we can see that the EPO right now was negative, positive. Now it's on neutral again. It's generally going positive here, which favors a breakdown of the cold pattern by the time we get to the end of February, beginning of March. And the PNA right now, which is negative, actually goes positive. So we get some cold air holding the pattern in place until the end of February. But then after that, it looks like it's going to go down here as well. And perhaps it might mean that the winter pattern might finally break down in early March. We'll see. So this is the current upper air pattern with the heavy rain on the East Coast right now on this Saturday, late afternoon and evening. So I wanted to point this out to you because notice what the trough here, there's your blocking pattern. There's your monster block. This is the Greenland block and the negative Arctic oscillation. This brown and white area goes all the way up into the North Pole, way off the top of the map, okay? There's your giant 50-50 low, huge ocean storm. There's Newfoundland, 50 degrees north latitude, 50 degrees west longitude, 50-50 low. This here is your negatively tilted trough. You see how the trough is running northwest to southeast like this? This is a severe negative tilt. And when you have a cold front of low pressure moving through the Midwest like this, approaching the East Coast, it always triggers rapid intensification of a very intense low pressure area. That's what we're going to see tomorrow when the cold front arrives. That low is going to track up through the Great Lakes, up at the eastern Canada, the St. Lawrence Valley, and then become the new 50-50 low. So that's why this is important. As I mentioned in the previous video, this event sets up the system on Wednesday, Thursday. There's the system for Wednesday and Thursday right there. You see it? Okay. Now, I wanted to point out to you, again, this is probably out of place here, but actually, I'm going to skip back to that. Let me jump ahead here. Okay, so this is the Saturday early morning European model. We're going to look at the Saturday early morning European and the GFS and maybe the Canadian and the British model, and then we'll look at the midday stuff, okay? Okay, and then the 18Z stuff. So what I want to point out here is this. You can see this upper lows right here. It's quite big. Let me enlarge it so you can see it a little bit. All right, and move this over to the side. There you go. So this is the big upper low right here. And you can see it's slightly negatively tilted here. But the upper low is in Iowa. And then what happens is there's your huge block. This is valid for Wednesday evening. So this is now producing low pressure here on the southeast U.S. coast. But the model from this morning on the European was taking the 500 low in Iowa and moving it almost due east to northern Virginia, Pennsylvania. And that allowed the low to come a little further north, and you're getting some sleet and freezing rain into North Carolina, eastern Virginia, the Delmarva. It's a huge snowstorm for New York and maybe Boston, Connecticut, D.C., Charlottesville, Hagerstown, Maryland, everybody just inland. But right in the east of 95 up to about Philly, there's a lot of mixing in this kind of scenario. And let me show you. This here is the GFS. Okay, the dark blue here, it's moderate to heavy snow. So this is from early Saturday morning, okay? So there you can see the snow. Here's the low developing. This is Wednesday afternoon at 1 p.m. It's snowing in all of Virginia at that point, and eastern Tennessee and Kentucky. All right, you're having some mix here in North Carolina. Now, by Wednesday evening, you have moderate snow in Richmond and into eastern Virginia, the Delmarva, but there's your sleet mix getting into Hampton Roads and freezing rain in North Carolina. Here, the low moves off the coast. You can see it right there. Now, Richmond is still getting mostly snow at this point, and there's sleet and freezing rains in southeast Virginia and Raleigh. But notice that on the model here, the northern end of the snow doesn't go much past the Virginia-West Virginia border. See that? And there it's moving off the coast. So again, it doesn't do much. And then finally, here it is off the coast. This is again early Saturday morning. This is the GFS taken off the coast. Now this says that New York City gets screwed out of the snow, so does Boston, Connecticut, Philadelphia. That's what this says. And then you get this kind of snow map. Look, nothing up here in Philly, very little in D.C., Baltimore. Okay, I think this solution is wrong. I think this is wrong. It's the GFS. It's probably wrong. Even though it gives, where my particular location in central and eastern Virginia, a huge snowstorm. So of course I would love it, but it's wrong. It's not the correct solution. Okay, this is the European model from this morning. Same thing. Now here, notice it's got much better low, much heavier snow in Tennessee and Kentucky. The whole precipitation shield looks much stronger here than it does on the GFS. Then here comes the moderate to heavy snow into Virginia and Ohio and West Virginia and much of Kentucky. Then you have your freezing rain and sleet in western and central North Carolina getting into Hampton Roads. This is Wednesday at 4 p.m. And then the thing reaches the coast. Look where the low is tracking, right along the coast. This is perfect for a Virginia, Maryland, Delaware, southern Pennsylvania, New Jersey snowstorm, right along the coast of Hatteras. Okay? And then moves off the coast here. You can see it. It's a pretty well-organized system. Let me blow this up a little bit. Okay, 997 moving off the coast. But the model has a lot of sleet and freezing rain into Richmond as far north as Fredericksburg, and all rain in Hampton Roads after a brief bit of snow and sleet. The rest of Virginia, western and northern Virginia is all snow. West Virginia is getting pounded, Maryland getting pounded, Delaware, southern Pennsylvania, New Jersey, and so on and so forth. And then from there, the European, this is now a Thursday morning, and you can see that this thing is really cranking. Okay, this was Thursday at 4 a.m., and then this is Thursday at 11 a.m. Now the lows moved very little at this point. You see what's happened? How come the lows moved so little? Because the upper lows captured it and the low slows down. And that causes a huge amount of snow to build up. So here, the low slows down. 991 moves very little in 6 to 8 hours. And it's gone back to all snow in Richmond. You're getting wraparound snow. And then D.C., Baltimore, Northern Virginia, Culpeper, Warrington, all of Pennsylvania, New Jersey, New York, Connecticut, Long Island, just getting pounded, just pounded. And there's the snow. This is now 6 hours later, okay? So this, if you look at the time here, according to the morning European, this is 4 p.m. Thursday, and this was 4 p.m. Wednesday, right here. Actually, Where was it here? So very little movement, as you can see. Very little movement here for a full day. Takes a full day just to go up this little far. And that's because it gets captured by the 500 low. Okay. As a result, you get this snowfall. So you got 5 inches south of Richmond, 8 inches of Richmond, 11 inches north of it. D.C., 2 feet of snow. Baltimore, 2 feet. Philadelphia, D.C., Trenton, Allentown, Harrisburg, New York, New Jersey, crushed. Winchester, 18, 19 inches of snow. Martinsburg, Charlottesville, 18 inches. Staunton, Roanoke, Lynchburg, 12 inches. Roanoke, 14, 15 inches. Now, the ensemble doesn't have that much, but it has more south side because the ensemble is saying that there's less warm air down here than the operational model. Okay. And here is the British model. British model, again, moderate snowstorm in Virginia, not that much in D.C., though, and then more up in New Jersey and eastern New York. Okay. This is the 12Z GFS. Now, this is very different, so let's go back to it. This is what the GFS, I didn't post the GFS, but let me show you what it was doing here. This is the GFS for 12Z. Now the GFS is a different solution here. The GFS has another negatively tilted trough, as you can see, right here. There's your block. This is valid Wednesday evening. See the negatively tilted trough? Okay, a big upper low in Minnesota and negatively tilted. This is a severe negative tilt. This is a rapidly intensifying, powerful coastal storm on the southeast U.S. coast embedded in Arctic air. Now, this next disturbance coming in from the west coast is very important because it forces the system to drive east. So it digs down and then it goes east off the coast. Digs down and goes east off the coast because of this piece of energy coming in here. You see that? That's what it does. And there's your low pressure area for, this is on Wednesday night, early Thursday morning, near Hatteras and heading out off the coast because this system is kicking it. This is called a kicker in the weather business. Now, this is the European at 12Z. Same thing. Same thing as this. Look at that. Same thing. Same thing. In fact, I'll move them out so you can see better. GFS, European. GFS, European. Identical. They both have the kicker, or there it is, as you can see right here on the European, just like the GFS. Severe negative tilt underneath the block, strong low pressure exploding off the coast. All right, the GFS. Here we go. Notice now the GFS precipitation here is much stronger and heavier than what we saw from early on Saturday morning. Let me go back to early Saturday morning. Much stronger. Look at that. Much heavier. That's Saturday morning. This is 12Z GFS. Much heavier. Okay. Now you have the 12Z GFS model. There's the low on the coast. It's gone over to sleet in Richmond, freezing rain in southeast Virginia and North Carolina. Heavy snow every place else, Kentucky, Virginia, southeast Ohio, most of Virginia, Maryland, Delaware. That's Wednesday evening, 10 p.m. This is now Wednesday. Let me bring it down a little bit so you can see it more. Well, this is Thursday morning, 4 a.m. There's a little moving off the coast. And now look where the low is going. It's going off the coast. See this? Look what it's doing. This is not coming up towards Cape Cod. This is up off the coast. As a result, you get a very strong northern edge to the snow shield. So New York City could get a foot of snow, but Poughkeepsie could get 3 inches. Providence could get a foot of snow. Boston could get 6. I'm just not saying that's going to happen. I'm saying you're looking at a northern edge of the snow shield here. Okay, those off the coast. As a result, there's the low going bye-bye. This is now here Thursday afternoon at 4 p.m. There's the low leaving southeast New England. Look again, you can see the track of it going like this. Right off the coast. And look at the snow. Nice snow map, 12Z GFS. You can see it's quite impressive. And let me change the color on this thing 1 second so you can see a little more. Okay. 15 inches in Richmond, 10 inches south side, 5-6 inches Hampton in Newport News, Williamsburg. Tappahannock gets crushed. Roanoke, Lynchburg, Charlottesville, Staunton, D.C., Baltimore, Dover, Salisbury, Philly, New Jersey. Great snow, all the way up into New York City, and then it kind of shuts off at that point in terms of the heavy snow. We look at the GFS ensemble. Now, this is important because what we're looking at here is a bunch of GFS models run at the same time. We're looking for a trend. We're looking for where the data is going. All right. And when we do that, this is from 6Z Wednesday, 6Z Saturday morning. And you can see, look at all the red numbers. These are all low pressure areas. You see all the clustering off the coast. All right. Now this is from 120. Yeah. Actually, let me change these maps around. You can see a little bit better that way. Okay. So here it is. All the lows right off the Carolina coast. And then look where it goes. See this? East northeast. Not northeast. East northeast off the coast. This is the 12Z GFS ensembles that we just looked. This was the operational model. This is the ensemble. There's the lows right there on the Carolina coast. Wilmington, okay, Charleston looking very great. Tremendous track for Virginia and Maryland, Delaware, western North Carolina. Then the low gets a little stronger here. The numbers are more coagulated around the center, right? But it's just to the southeast of Hatteras. And then from there, look where it goes, east-northeast off the coast. Not northeast, not towards New York City, not towards Cape Cod, east-northeast off the coast. Perfect track for a major snowstorm in the lower middle Atlantic. You could not ask for anything better. Now, this is the GFS snowfall ensemble, which doesn't show much. The ensemble is often much lower than the operational model, so that does really concern me. It's the position of the low that concerns me. Now, here's the European model. Again, look what it's doing. Negatively tilted trough. It looks just like, the GFS as I showed earlier. It looks amazingly close. Really, really close. And the result is a very similar type of thing, but the European is slightly stronger with the cold air. This is now on Wednesday morning at 11 a.m. Okay? So the snow is just getting into southwest Virginia. Tennessee's getting hammered. Kentucky, Missouri, northern Arkansas, southern Illinois, southern Indiana. It's moving into southern Ohio. All right? There's the low way down there in the Florida Panhandle. Now it goes to the Carolina coast. Heavy snow is now in central and southern Virginia. Southwest Virginia is just getting slammed. Northwest North Carolina is all snow. Hickory, Greensboro, Asheville, Boone, getting plastered. Kentucky getting hammered. West Virginia getting hammered. The snow has reached Baltimore and D.C. and probably Salisbury. Okay? This is Wednesday afternoon, 4 p.m. Now, here is the European. This is the 12Z run again from this afternoon. Came out around 1 p.m. There's the low right along the coast and moves. Look where it goes. Off the coast, not to Cape Cod. This way, east-northeast. See that? And look at this. So as a result, the Richmond metro area stays all snow. So does Charlottesville. So does Greensboro. So does Danville and Lynchburg and Tappahannock and the Northern Neck and Southern Maryland and Delmarva. Okay, there is mixing in Hampton Roads. It goes back to snow by a Wednesday evening as the low pulls away. And then the low is gone, and you're still getting wraparound snow Thursday morning from Long Island to New York City, down to New Jersey, Philly, Baltimore, into Richmond, the Middle Peninsula, Northern Neck, and Hampton Roads, as the low heads off the coast again in this direction. And the snow map, this is the British model. Now, this is the 12Z run, and look at the difference between the 0Z run. Early Saturday morning, midday Saturday. Much more snow in the Mid-Atlantic area. Here's the 12Z European. Jesus, Joseph and Mary. Yeah, 19 inches in Richmond. I don't know if that's going to happen, but it definitely is snowier than it was before. Okay? And now, taken verbatim, let's go back to this, taken verbatim. Again, let me change the color in this thing. There we go. It's got heavy snow in Hampton, in Williamsburg and Newport News, and even a few inches in Virginia Beach. Raleigh is to the north of it. It's mostly sleet or freezing rain in here, but you can see it's got 20 inches in Roanoke and Lynchburg and Charlottesville and Staunton, or close to it. 15 in D.C. and Baltimore. Right? 10 in Philly and southern New Jersey. 12, 15 inches in the Delmarva. Now here, because the low is going off the coast, it has much less snow in New York and New England. Right? So, and this is the Canadian. Canadian's a little warmer, as it always is, and it's got the low further north. You see it's got the low almost by Wallis Island, and then it goes off the coast. So, we'll see. And then it goes back to snow at the end. But even on the Canadian, with the low this far south, notice the northern edge of the heavy snows right into New York City. Not much past that. Now, I don't use the Canadian for much. I don't think it's that good of a model for East Coast storms, but I'll just point it out there. Now, to show you the European ensemble trend, just like we looked at the ensemble trend here, let's look at the trend on the European ensemble. Okay, so here we go. I have to change the color on this again. There we go. In fact, I'm just going to copy it. There we go. So this is 6Z, Saturday morning. It came at 6 a.m. Look where the lows are. See it? Along the North Carolina coast. And then this is 12Z, tightly clustered along the North Carolina coast. Same. Looks pretty good. Now, this is 6Z, European, valid Thursday morning, 7 a.m. Look, see where the low is? Here. See where the low is? Here. Same thing. Moving east-northeast off the coast. If anything, this is a little more east than it's almost due east of Hatteras. See that? This is a little about the same, really. So there we go. So very consistent here. This is the 18Z European, which is just a gargantuan historic snowstorm for Richmond, if it's correct, in central Virginia. And you can see the low just moves off the Hatteras coast, rapidly intensifies, and just bombs Richmond, Petersburg, Fredericksburg, Charlottesville, Tappahannock, Salisbury, Dover, D.C., Baltimore, southern New Jersey. Just bombs it. Really just crushing snow. And it snows all the way into midday Thursday. Notice again right here, northern edge, right there, New York City. Now, I don't know if this is true. This could go further north. I'm not saying it's going to happen. But again, the trend, all the data, east-northeast. East-northeast. And why? Why is it going east-northeast? Because of this kicker coming in behind it. Right here. It's kicking the system to the east so it doesn't get a chance to turn off the coast. That's really what it is. Okay. And then this is the 18Z snowstorm map. This is a record snowfall for Richmond, by the way. Richmond would break the snow record if this is correct. I'm not saying it is correct. I'm just letting you know what it's doing. It's pretty freaking amazing. Okay. This is the European ensemble, and this just shows you the trend. And again, this is now the latest run here. You can see that the model is now up to, if it blows up 10, 11 inches. A few days ago it was showing 3 or 4 inches, then 5 or 6 inches, then 7 or 8 inches. Now it's so as we're getting closer to the end, as we're getting closer to February 20th, the numbers are going up. This is the European ensemble for Washington IAD. You can see that the operational model is around 10 inches. Okay, the ensemble mean is around 8, right? So, but you can see there are a lot of members here showing much more than 8 or 10 inches of snow. And then this is the GFS ensemble from 18Z. Again, look how far east it is, moving off the coast, just not doing it. Not doing the track you need for a big New York City, Boston hit. Okay, so an overview. Yes, this is going to be a Costa and Uccellini snowstorm event. There's no doubt about that. Saturday trends with the GFS and the European ensembles. Oops, got the spelling there. Sorry about that, folks. Take the big low east-northeast, not northeast off the coast. This implies more snow, less ice mix for western and central North Carolina, southeast Virginia, and the Delmarva. The northern edge of the heavy snow, question mark. Philly, New York City, Connecticut, I don't know. But it's going to be an issue if this trend continues. Okay. Based upon the current data, places that normally don't see significant snow accumulations could see major snow accumulations from this event. This would include Hampton Roads, and of course Richmond, obviously, the peninsula area, Williamsburg, Suffolk, and Raleigh, Greensboro. But Raleigh, Greensboro might be all ice or a mixture. Well, I don't know that yet. Okay. Based upon all the data, the atmosphere is cold enough for this event to be primarily a snow event, with any mixing restricted to central North Carolina, Hampton Roads. Of course, that could change. Now, the temperatures on Wednesday look impressively cold. If the temperatures are as cold as the data is showing Wednesday morning, the clouds come rolling in, your snow ratio is going to be much higher than 10 to 1. So let me show you what I mean by the temperatures here. These are the temperatures Wednesday morning. Look at this. At the beginning of the event, okay, you're in the teens. The European model has snow in Tennessee and Kentucky, temperatures between 15 and 25 degrees. Are you kidding me? Yeah, no, that's what the European is showing. Same thing here. Look at this. 22 degrees in Richmond, 17 up in D.C., 21 in Charlottesville, 24 in Roanoke, 25 in Raleigh. When the precipitation comes in, that's really cold temperatures. All right? And the 850 temperatures, there it is. Okay, this is Wednesday morning at 5 a.m., 6 a.m. The yellow line is the rain snow line, so you can see how cold the atmosphere is north of that. Everything north of that yellow line falls as all snow. Now, that's going to change as the storm gets cranking. The yellow line is going to get close to the North Carolina border. But for the most part, it doesn't go any further north than that. That's why Virginia gets pounded in such a big snow. Okay. So I wanted to point that out to you. All right. So there we go. All right. And finally, I'll be issuing new updates tomorrow. A new model's coming out later on tonight, whatever. You can follow me on the Blue Sky page. I want to make sure you all knew what it looked like. This is the Blue Sky page. It's free. You don't have to join it. Just click on the link and you can see the updates. Just thought I'd point it out to you. Nice and clean and safe. No yelling or screaming or carrying on or ranting or raving or conspiracy nonsense from the bullshit you see on Twitter and that nutcase Elon Musk. Okay, anyway, hopefully you enjoyed the presentation. And look for new updates during the overnight hours and do a new video tomorrow. Now, once we do the new videos coming in tomorrow, some of the stuff we won't be talking about. We won't be talking about the teleconnections anymore or the current pattern. We'll just be going into the snowstorm. All right, thanks for watching. This is DT from Weather Risk. I'll see you over on the Facebook page, the website, and over on the Blue Sky page.